Physics is often described as the science that explains how the universe works. We learn why objects fall, why planets move, and why heat flows from hot to cold. But explanations alone is not enough for what gives physics its true power. The real strength of physics lies in its ability to predict what will happen next, and the ability comes not from words, but from mathematics. Long before equations existed, people carefully observed the natural world. They watched objects fall, noticed that faster motion covered more distance, and recognized repeating patterns in the sky. These observations allowed nature to be described in words. Descriptions helps us organize experience and explain what we see, but description alone has limits. It tells us what happened, not what will happen. Words can describe motion as fast or slow, heavy or light, violent or gentle. But words are vague. Without numbers, there's no way to calculate exactly how far something will travel, how long it will take, or where it will land. A description may sound convincing, but it cannot reliably forecast outcomes. In ancient times, thinkers explained motion using everyday language and philosophy. Objects were said to seek their natural place, and motion was classified rather than measured. The ideas were descriptive and intuitive, but they offered no way to compute results in advance. Without systematic measurement and mathematics, physics could not move beyond explanation into prediction. A major shift occurred when scientists began to measure motion itself. Time was tracked, distances were recorded, and motion became numerical. Once quantities could be measured as numbers, relationships between them could be studied. This marked a turning point in physics, where observations no longer just described, but quantified. Mathematics allows vast amounts of information to be compressed into simple equations. Instead of listing countless observations, a single mathematical relationship can capture them all. An equation is not just a calculating tool, it is a compact statement about how nature behaves. Once physical laws are written mathematically, prediction becomes possible. Scientists can calculate where an object will be in the future, how fast it will move, or how a system will evolve over time. Experiments no longer have to wait for events to happen. Outcomes can be predicted first, then tested against reality. With the mathematical formulation of motion and forces, physics entered a new era. Given the starting conditions of a system, its future behavior can be calculated. The motion of falling objects, projectiles, and even planets could be predicted with remarkable accuracy. This approach did not end with classical physics. Modern physics continues to rely on mathematics to turn observations into prediction. From the motion of galaxies to the behavior of light and energy, and equations remain the bridge between what we see and what we can foresee. Physics can exist without mathematics, but only as a description. Mathematics transforms physics into predictive science. It allows us to move beyond explaining the past and toward calculating the future. That's why mathematics is not just a tool of physics, it is the language that gives physics its power. Thank you for watching.